Good morning. Today we're starting 3.6. We are gonna solve inequalities. Today there are going to be nonlinear inequalities. However, what I mean is you expect to see a polynomial in the inequality with degree or exponent 2 or more. So nonlinear means you have a polynomial or a rational expression, but it's definitely not a simple equation. Okay, so I want to compare what's new in this section to what you already know from past sections. You guys know how to solve this, right? 2y minus 18 greater or equal 0. Solve means isolate y. If you only have a single y, no powers, you see it's degree 1, exponent is simply 1. We simply add 18 to both sides, and later we divide both sides by 2. And you get y equals 9. Y greater or equals 9. That's easy. This is called linear. In other words, power is exactly 1. Okay, you may have several spot with y's, but you combine them if you need to. But the case today we're gonna do is, what if your expression is a polynomial? It's nonlinear. It has powers more than 1. Look, it's not just y here. You have y squared, y cubed, y to the 4th. How do you attack these questions? Because you can't just leave y alone here, because there are y's everywhere with several exponents. So here is what you need to do. This is the rough method we apply both to polynomials and rational inequalities. By the way, rational inequality is something like this or this. A ratio inequality, and on the other side you have a number, or usually 0. This is a rational inequality. Here, this one or this one is called polynomial because you don't have a denominator. First of all, before anything else, you need to make sure the right hand side is completely 0. This is right hand side and it's completely 0, so you do not have to worry about step 1. It's already 0. If it's not, you need to bring everything to the left and make it 0. Okay? In this problem, for example, I need to move 3 to the left. Move it. Okay? Alright, step 1 is okay. Now, step 2 is, although it doesn't give us much details, we need to determine some boundary values. But there is a pre-step. Actually, there is a step between 1 and 2 before this we need to do. It's called factoring. To be able to set this, this is called, by the way, the left side is called f of x. This is f of x. And they say decide what values make f of x undefined and what values make this f of x 0. But to be able to achieve this, you need to first factor. So I will insert here factor f of x, then do whatever it says the next. So there is a secret step actually we need to involve here. We need to first factor f of x. Because come on, it makes sense. That's why they skipped this step. Because to be able to solve this function set into 0, you guys need to factor it. There is no other way. You need to find zeros of this function. So find zeros of this function. Now, one way is, again, I said, is factoring. But can you guys factor this thing by hand manually? So I have minus 3y to the 4th, 3y cubed plus 24y squared minus 36y. Can you guys factor this? This is a 4-term expression. You may try factoring 2 by 2. But before we start into four-term factoring, there's actually one thing you can search and get it out of everybody, which is 3, greatest common factor. There is a number or variable common everywhere. It's not just 3 though, also y as well. So I can call 3y out, and this thing becomes only y cubed, negative y cubed. Actually, I like to call minus 3y out because I don't like having a negative in the leading term here. So I will take minus 3 out, minus 3y out. So this is going to be minus positive y cubed. This is going to be minus y squared. This one is going to be minus 8y and 36, positive 36. You see all the signs have flipped. Positive y cubed, negative y squared. 24 is negative 8. 36 is not 36, right? I made a mistake here. What is this? Divide by 3, negative 3y. It is 12. Okay, usually this is what I do, but don't write this. You group this 2 by 2 and search for something common. I see only y squared common here and then y minus 1 left. Here I see 4, minus 4 common. I get my y minus 3. However, there is nothing common in these parentheses, right? Is there anything common? So they won't regroup, so I quit this method. It's not working. This is called factoring by grouping, 2 by 2 grouping. It's not yielding anything, so I quit it. So what is the other way to find zeros if factoring, direct factoring is not working? Factoring is not working. How can I get zeros of this thing? Yeah, remember the exam questions. How'd you find zeros of a polynomial like this? You need to go hunting, right? And you need to try, I need some candidates for zeros. How do I find those candidates? Come on, anyone? P over Q. We do search for rational zeros first. So I need to, P is the factors of 12, which is 1, 2, 3, 4, 6, 12. Q is the factors of the leading number, which is 1. So one of these guys with pluses and minuses, so here is the list, plus minus 1, plus minus 2, plus minus 3, plus minus 4, one of these guys is a 0. One or more. I don't know how many. It can be as many as 3 of them. Do you guys know any? So we can kind of cheat. I don't want to test everything 1, 2, 3 by synthetic division. I have a feeling 3 maybe. So I'm going to test 3. I will take minus 3 here, 1, and I'll do synthetic division. Yep, I was right. I found the first 0. X equal minus 3 is a 0. That means x plus 3 is a factor of the polynomial. So far I have this then, minus 3y. No, not x, I'm sorry, our variable here is y. Please flip these to y's. So far our polynomial here broken into 1, and the second factor is y plus 3. What is the remaining piece? Y squared minus 4y and 4. Okay? Next, can you break this? Come on, it's a quadratic now. Second degree polynomial. You can do this by hand. You don't need to fish in this tank. It's waste of time to do that. You can break this by hand. Does anyone know how to break this? Chris?
1 minus 2. 1 minus 2.
Y minus 2, y minus 2. Perfect. I have now that expression, this entire expression, completely factored as minus 3y, y plus 3, y minus 2. Can I call this squared? Make this a square. You don't need to write them separately. Greater than 0. So put this under the box, inside the box, because this is important. Now what are we going to do with this? I factored it. Now I'm going to find out what x values, or in other words y values, make it 0. Besides, I need to find any of x values that can make this thing undefined. So you need to name zeros, and you need to name also the values that makes this function undefined. So are there any values you insert in y and makes this left side undefined? Are there? Anything? No. It's a polynomial. What's great about polynomials is their domain is entire real line. Nothing bad about these. But I believe when you come to this question, there will be some bad values that makes this function undefined. So in this part, there will be some undefined values. Okay. Here we have only zeros. And they are, what are those zeros? Minus 3 from coming this, and only 2. Is that all? Do we have only 2 zeros? I missed one. What is it? 0 as well. This guy. Y minus 0, this means. Y minus 0, that means 0 is a 0. There are 3 distinct zeros. Actually 4. 1, 2, 3, 4. This is a double. This is multiplicity. Multiplicity 2. This shows up twice. But all I need is how many different ones. Now what is next? Very close to the result. What I'm gonna do is take a real line. Why do I need these 3 values and also undefined values? Because these are called boundary values. I'm not gonna call them zeros anymore. They are called boundary values because when your function hits these values, it's very likely that this function can flip signs. It can be positive to the left of those numbers, and to the right it becomes suddenly negative. They are called boundary because when you pass this value, something opposite can happen. Okay? Zeros are kind of neutral values, but before zeros and after zeros, function can be opposite signs. And why do we care about signs of this function? Because look what it says. This sign means when does this function, polynomial, when it becomes positive, 0 or positive, right? Positive or 0. When it's equal 0, it's 0. But when it's more than 0, we call it positive. So all I need is make a table here, and these are the neutral values, and check the function values between these boundary values. Okay, first off, you need to first line these up, these numbers, sort them from smallest to biggest, and put it on this line. So where is 0? 0 is right in the middle. Where is minus 3? Minus 3 is 3 left, somewhere here. Where is 2? 2 is somewhere here. Now, I need to just discover, this is your f, this is f of x, or f of y. I need to discover the signs of f on each interval. How many intervals do we have here? Here is 1, here is 2, here is 3, here is 4. There are 4 regions. This function can change signs, or maybe sometimes stay the same, but possibly can be different signs. Here it can be all positive, here it can be negatives, here it can be positive, and here it can stay positive. We never know. So we have to test them. We have to test on over each interval what kind of sign f attains. Alright, so how can I figure out really before minus 3 what this function will be, positive or negative? How can I test it? What's the easiest way? Before minus 3. I want you to test it here on this region. How can I test this f of y is positive or negative there? Anyone? Plug a value from that region. So what value would you rather have? Something less than minus 3. Negative 4? Yeah, just take the next whole value, not negative 3.65. Okay, it's hard to manage that number here. Just take the whole next power, such as test y equals negative 4 here. So I actually like doing that with a table. You have four intervals to test. I need 4 columns. Okay, so take y values here, your variable, and compute f of y under this function. And you are testing negative 4 first. And what kind of number you don't have to compute entirely. Look, I just do it on top of my head. If I put minus 4 here and take away minus 2, when I square it, what kind of number is it? It's a positive number. Negative 4 plus 3 is a negative number. Negative 3 times negative 4, it's a positive number. What happens if you multiply plus, minus, and plus? It's a plus, minus, plus is it's a negative number. Well, do you really want to compute it? Yeah, take a calculator and multiply minus 3 times minus 4 plus 3, and minus 4 minus 2 square, multiply all, and compute this. But I don't need the digits here. All I need is sign. So what does this sign tell me? This sign tells me that, oops, sorry, it looks like I lost my critical values or boundary values. Negative 3, 0, and 2. This sign tells me that the function is negative on this region. It's negative. In other words, this means less than 0. We want more than 0, right? Always keep in mind what we are going after. We're going after the region that makes my function positive. 0 or positive. This is less than 0, so can I kinda ignore this? This is not what I'm looking for. Okay, let's check the next one. What do you want to test next? Test y equals a value between minus 3 and 0. What's the best one? Negative 1 is the best, rather than negative 2, negative 1, because I like 1. Raising powers of 1 is so easy. I'll take negative 1. But let's do it again. This is positive. No, yeah, it's positive. This is positive as well when I put negative 1. And this is always positive because of the square. No matter what you insert here, it's always positive. What happens when you multiply 3 positive things? It's positive. So I got the next line positive. And this is great. I'm actually going to frame this region. I like this region because I'm looking for where that function is positive. I even put a heart on it. I like it. Okay. This region, -3 to 0, it's positive. Perfect. Next, I test what value? Test something here. Z between 0 and 2, the only value makes sense is 1. Okay, when I insert 1 here, signs change, of course. This is negative. This is positive. This is positive. The answer is negative. Negative, positive, positive multiplies to negative. And this is again bad. I didn't like this because I'm looking for positive regions, so forget this. And the last one, what value we're testing? Something more than 2, 100. Now let's go easy. 3. Plug in 3. Negative, positive, positive. So it's positive. Usually you expect to see sign change. If you start with negative, it keeps positive, negative, positive, negative that way. But don't take my word granted. It may be sometimes different. It may stay the same all the time. But usually, I'm saying, usually, often, signs flip in each boundary point. Okay, so this is positive. And did you like this region? Yes, I'm going to put this also inside a box because we are looking for what again? We are looking for when this thing 0 or positive. This sign means you can be 0 or positive. And what regions are you positive now? So the solution we've done is there are 2 regions. First, what's this interval? -3 to 0, right? Union, the second one is 2 to where? What is the end point? Infinity. Okay, final word. Is this the final solution? No. We have to check something. We have to check something. This is it. Do you see equal sign here? Do you? Okay. Then you need to test out these boundary values, or in other words, these end values in the inequalities to see if these numbers make the polynomial 0 or not. Okay? And if these were the zeros of the polynomial, yes, they will. Look, weren't they the zeros of the polynomial? Where did we name them? Here. 0, -3, and 2. You don't have to test them. -3, 0, and 2 were zeros of the polynomial, so they will make the polynomial equal to 0. So I will include them in my solution. Instead of parentheses, make them brackets. So when these endpoints may not be included, then when is this 0 should be excluded? If it's an undefined value. Important. Just because you have equal sign, you will not make a bracket all the time. Sometimes it can be parentheses because that value can be an undefined value. When you insert it into the polynomial can be undefined. Okay? Got it? So let's try this. Please read and see what format the answer should be. It's interval notation. Sometimes it may say set builder, so you need to make set builder notation. But here, this is just -3 to 0. Oh, it was brackets, right? Union What was it? 2? Oh, I forgot. We cannot have a bracket with an infinite. What's the problem?
Wouldn't the last value when you plug in 3, shouldn't it be negative? 'Cause 3
Probably.
times 3 is negative.
Yeah. Negative, positive, negative. Why'd you wait so long? Thank you. Yes, it's negative. Negative, positive, negative is negative. If the last one is negative, then it's not an answer. Sorry. You have to take this back. Clean this out as well. It's a negative sign. So it's a bad region as well. We don't care about this. So I have to take it out of my intervals. No union anymore. It's just minus 3 to 0. Uh-oh. We forgot 2. However, though, we should have taken this guy in. Why? So many mistakes we made today. Why should we take this 2 in? Because it's a 0 makers. We found zeros here, right? And we are allowed to have function to be 0. So you not only take positive numbers, positive makers, but also 0 makers. End values are already in minus 3, 0. We also need that 2 as well. Okay? Because since 2 is a single point, you just need to list it in set parentheses. Set parentheses like this. Okay? Basis. So I got 0 credit on this question unless I try another one. But it's gonna take another whole session to solve this, so I'm skipping this, okay? And you found out my mistake, right? So that's why we have only so few questions here. They take a long time. And if you rush like me, I did rush and I didn't check my work, so many mistakes can happen. Okay? Let's take a look at the second one. There are 5 parts here we are going to make. These are going to take shorter. And I put this question in here because not all questions needed to be solved with this long procedure. Sometimes for short, well-known polynomials like quadratic ones, you can use your logic. You don't need to make that line, boundaries, find zeros. Use your logic if it's simple enough. So we are going to use logic on the following parts, but not this one. This is not an inequality. This is equal sign. So if they want us to solve this, this is past sections. How do I solve a polynomial, set it into 0? I need to factor it. Let's factor. And we already factored in question 1, right? What is the factors of this thing? It's what 2 numbers multiply to 4 and add to minus 4? Minus 2, minus 2. So you have actually these two things matching. So you end up with the same 0. A is 2, A is 2. So there is a single solution here, which is 2. That's it. Part 1 is so easy. Only 2. How about part 2? Part 2 is something new. They want us to find over what interval this thing is negative. Okay? Actually, you can just type in here. Sign flip to this thing. But do I still change my method? No, I will still factor this. It's just asking me that. Now look, use your logic. You don't. Oh, now do you want to test zeros and make this table and find zeros and boundaries and do? No, use your logic. What does this read as? You have a number, you're taking 2 off and squaring it. This is the square of an expression. It says when a number take 2 off and square it becomes negative. What numbers you pick, take 2 off, square it and it becomes negative? None. Always square of a number, this thing is positive. So the solution set here is empty set. This is empty. If you repeat my work here, do the same thing in question 1, find zeros of this thing you already did and make the table, you will end up with the same thing. If you make this table, the boundary point will be 2. You will end up getting negatives on this side, negatives on this side. There is no valid, no positive, sorry. It's always positive everywhere this expression is. Just test a value. Test, for example, 3. Test 1. When I put 1 or 3, this thing is always positive. So there is no negative region. So this is empty set. Make sense? This one is empty. Should I use this or this? I think either one is work. Yep, this work. You can use the other symbol as well. Now, question slightly differ. What did they do? In part C, they put equal sign. Do you see? Always compare the new part to the past, earlier, previous parts. They put a squared minus 4a plus 4 and equal sign. I know I want to mark it so you don't miss it. Equal sign now. So what is the difference? Oh, isn't this the same thing? This thing can never be negative, so it's empty set. So I believe this is always positive. And this means when it's gonna be negative, and I will go ahead and say empty set never. Am I right? Now this says negative or 0. So you have, I know this is never negative, so empty set is the answer of this one. But 0, it can be 0 for some values. What value makes it 0? 2. So I need to put 2 in. Count 2 in this time. Okay, next. This one is tricky though. They flip the sign this time. When does this thing become more than 0, positive? When? Yes. This is positive means strictly you're not allowed to be 0. Not allowed to be 0. Look, we cannot be 0 because there is no equal sign. No equal sign, you need to stay more. And I know this thing becomes 0 sometimes if a is 2. So you need to take that away from your solution set. So whole set, everything is your solution except 2. So this is your solution. You can take 3 or more, but not 2. You can take anything less than 2, but not 2. So the answer is minus infinity to 2 and 2 to infinity union. And the last one, when does this thing become 0 or positive? Every number. This time everything is good because it allows us to be 0. So I will put minus infinity to infinity. Okay? Any questions? Alright. In the next half of today's class, we're going to take a look at ratio expressions, so rational expressions. Ratios are involved now. How do we attack these questions? First off, we need to bring the right side 0. It's a must. Step 1, if you don't see 0 on the right side, get that 0. So how can I remove this 3? How do I remove that 3?
Subtract 3 on both sides.
Yep, we subtract 3 from left and from right. So it is minus 3 on the left now. Okay, there is a secret step here as well. It is, you need to bring the left side into one fraction. Make everything into one fraction. So I see a fraction and a whole number subtraction here, which is no good. I need to bring them all into the same fraction, and then we will do what it needs to be done in step 2. What do I mean by bringing it to the same fraction? This is a subtraction. You need to perform this subtraction, put 1 under. You need to combine these two fractions. There are two separate fractions now. How do I combine two fractions? We need to get common denominators, right? So this one will need x plus 5 multiplying both top and bottom, correct? So it is 3 minus x, and then minus 3 times x plus 5, and all together x plus 5 is common denominator, so I combine them. And we need to simplify the top as much as possible, so it is 3 minus x minus 3 times x, and but minus 3 times 5 minus 15 over x plus 5. Alright, I see two like terms. These two can be combined, right? They make, oh, these two as well. These are like. So x is with x constantly, constant, so you get minus 4x minus 12 over x plus 5. Am I right? Now we are ready for step 2. Again, if necessary, you need to factor top and bottom separately. Do you see any factoring going on the top or bottom? There is a minor factoring on the top, which is not going to make a great change though. Don't we have something common between here? Minus 4? Yeah, minus 4. 4 divides 12 as well, so I'm going to factor a minus 4 and get this. This is optional. You're not required to do, but I insist doing it. What can I do? What do you think I'm gonna do? It's going to make our expression better looking, simpler looking. Have a feeling what I'm gonna do next? No? Before describing what's undefined and zeros of this thing, I will do one more prep step. No? Okay, hint. Is there any way I can get rid of this 4? Looks like it's useless. It's just multiplying the top. Is there any way you can get rid of it? Come on. How do you get rid of a 4? In an equation or inequality? Huh? Yeah. You can divide both sides by -4. And I obtain x plus 3, x plus 5. What is 0 divided by -4? It's 0. Spot a mistake, a huge mistake. It's going to make my answer completely incorrect if I continue like this.
Didn't you have to switch the sign?
Yes, that's the mistake. When you divide both sides with a negative number in inequalities only, not equal signs, but in inequalities, you need to flip the direction of the sign. Alright, I can't get a hold of myself. I get carried over and I want to do this. Can I also multiply both sides by x plus 5 and cancel this? Can I? Can I? Can I do this? This is very important because we've been doing this so many times in equation solving. I want to talk to you guys this thing. Let's say you have an equation like this and I want you to solve it. Or let's take a look at this. When I ask you to solve this, this is what you guys do. You put this into factored form, x plus 2, x minus 1, right? No, the other way. X minus 2, x plus 1, right? And then what happens if I decide to divide both sides to eliminate one of the factors? Can I do that? Yeah, it looks like I can. When I divide both sides with this x plus 1, 0 over x plus 1 is 0, and I get the result. I say this is the solution. This is the only 0 of this polynomial. Am I correct? Yes, I'm correct. This is a solution. This makes this thing 0 if you plug in 2 squared minus 2 plus 2. What happened here? Everything is up to code. I did everything right, correct? No. I have, by dividing both sides with a variable factor, I have lost the other solution, which was x plus 1 equals 0. When you said it, the other solution, there are two solutions here. I have lost it because I have divided both sides with a variable expression. So you need to be really careful when you're dividing both sides with variables, because when you do that, you lose some part of the solutions. Although this looks like official, you can do it mathematically. No, you are risking losing a solution when you multiply or divide both sides of an equation or inequality with variables. So don't do that in inequality solving questions. So don't do that. This is all false idea. Never ever divide, what happens? Never ever divide any side of an equation with variables. Constants are fine. Don't multiply or divide by variables. You may have lost a solution. Okay, what do we do next? You need to describe what makes this thing 0 and what makes this thing undefined. I will start with undefined values. Undefined values are the ones that makes the denominator 0. So when is this thing 0? -5. So can I quickly say, instead of this, undefined values that are -1. -5, sorry. Okay, what are the values that makes the function, entire function f of x 0? When does this become 0? Yeah, actually, it's easy to predict on this question because it's so simple, but sometimes you may have this thing. Okay, you may have more and more stuff on the top. All you need to do is, no matter what complicated the situation is, always take the whole thing into 0, set it into 0, and wipe the denominator off. You can wipe this off. Why? There is only one time you're allowed to multiply both sides with a variable is if this thing is 0. Okay? So when I multiply both sides with x plus 5, 0 times x plus 5 is 0. So all you need to do is solve this thing now, which is x equal -3. And these are going to make our boundary values. Put them in here. -5, -3. But I want to put a hole here. Hole. Instead of a regular match, I want to put a hole. Why do you think I'm putting a hole there, not this one? Because this one is in the domain of my function. You're allowed to enter this into function, but -5 you are not allowed to enter it into function. It's not in the domain. It makes your function undefined. So in your solution, you should never ever include this value in your interval. Okay, because it makes your function sick. Now we are going to test. I'm going to test a value from this room, like -6. I'm going to test a value here. What's the best value here between -5 and -3? 4, -4. And the best value for here is? There is a better value actually. Other than 1? 0. I mean, if there is products of things, 0 makes things 0, so it's easier to test 0. But 1 is fine, -1 is fine, it's your choice. So here is the function we're testing for signs of x plus 3 and x plus 5. What is our goal? We want it to be negative or 0, 0 or negative. So when does this become 0? When does this become negative? So we will take our colored pen and describe those regions. So for -6, I'm testing -6 now. -6, -6, -6 plus 3 is negative. -6 plus 5 is negative. And you divide negative by negative, it makes positive. Just take a number, compute this if you wish. It's -3 over -1, +3. +3, this makes when you enter -6, it's positive. Okay, next region. We are testing -4. -4, -4. -4 plus 3 is -1, negative. -4 plus 5 is +1, positive. -1 over +1 is negative. This time it's flipping signs. It looks like everywhere. I'm guessing the next one is gonna be positive, but I can't be sure. I need to test it, okay? So now let's insert 0. We are testing 0. And I'm right, 0 plus 3, 0 plus 5 are both positive. When you divide them, it's positive. So what regions are we going to consider as a solution? Only the middle side, because we are testing when this thing is negative. So the solution is, let's interval this from -5 to -3. That's it. I count the end values in. They are brackets, not parentheses, because we have equal sign. We are okay with being 0. Agree?
-5 shouldn't be included.
Yes. I am incorrect. Just because you have equal sign doesn't mean you need to make every parenthesis a bracket. You cannot make undefined value included. So undefined value should be always excluded, -5. I put a 0 there, right? That means you need to exclude it all the time. This should be the answer. Any mistakes before we try? No? Okay. What was the other value? 3? Oh. Yeah, now we're good. Glad I got this one right. Alright, our last question is a short type. It's all the same expression, 4 different scenarios. This means 0 or negative. This is just negative. This is 0 or positive. And this is just positive. Okay, look, you can use your logic here. You can answer these questions by logic, because these powers, do you see these powers? What kind of exponents are these? And signs, look at these. Those exponents are always even, 4th and 2nd degree power. They are even exponents. So they make everything positive. So it's gonna make here positive number, and you're adding something more, another positive thing, and you divide, take ratio of these positive things. I think this is gonna always forever become positive. This left side is always positive, and they're asking me when it's gonna be negative. Can it be ever be negative? No, it's always positive. Question is, 0 is allowed. Are there any values you insert in A and this ratio is gonna be 0? Are there? Just set that into 0 and check. Again, if a ratio is set it into 0, you are allowed to multiply both sides with the denominator. A to the 4th is 0. What number raised to the 4th power is 0? Take 4th root of both sides. 4th root. They cancel. A is 4th root of 0. What number multiplies itself to 0 4 times? 0. So there is a number that makes the inequality equal 0, and everywhere else is positive. So we have to exclude that value. Take 0 away and count everybody else. Okay? This is by logic. But if you don't like this logical option and you want to do everything from scratch, you need to first, step 1, make sure the right side 0. Yes, step 1 is okay. Step 2, you need to see if there are any undefined values. Are there any undefined values that makes the denominator 0? A squared plus 4, can it be ever be 0? Check. Test it. I subtract 4 from both sides. None. No number 1 squared becomes negative. No undefined value, but 0 value. Are there any values that makes this 0? Yeah, we already tested out a minute ago. A equals 0. So there is only one boundary value here, 0. You need to test the right side. It's going to turn out positive. The left side is going to be positive. But we have to exclude this from the whole domain because it makes the function 0. It's a good value. Okay? So the only time, so the earlier answer was wrong. It's saying where this thing is negative, right? And it's never negative, but right? It's never negative, but only it's 0 at here. The solution is 0. We shouldn't have excluded 0. 0 was the solution actually. I thought this was the other way. So 0 is the only thing that makes this thing true. So the solution is for part A just 0. Next, does this thing ever become less than 0? Look at the table. You can test values to the left and right of 0. Never. So this is empty set. You can use this notation or this one if you like. Okay, can this be ever positive or 0? Yeah, it's either exactly 0 or everywhere positive. So the solution set here is entire real line. So it is negative infinity comma infinity close. Alright, when is it strictly more than 0 then? 0 is not allowed. The first answer I gave earlier. We need to exclude this thing and count everybody in. This is the right option. Okay. Any questions? This was kind of fast, but let me know. Again, I kind of fast forward. I applied these steps. I found what it makes the function rational expression undefined, what it makes it 0, and I figured there is no value makes this undefined. Only case that makes it 0 is a equals 0. So I put it on the chart and test a value before 0 such as -1 or a -1, and I test a value after 0 such as 1. If you want to test them, you will observe that they are always yielding positive results. Right? Test -1, -1 raised to the 4, -1 raised to the square plus 4 is positive. We have figured that this is always positive, never becomes negative, but 0 is allowed. So the only case that makes this statement correct is a equals 0. That was the first answer. And it never becomes negative, always positive. But if you want to avoid being 0, you need to take this answer away from the real line. Negative infinity 0 is the last part answer, and 0 to infinity as well, union of them. The other two cases are just opposite of these situations. Negative, never negative. 0 or positive, yes, everywhere. So you either have empty set or entire real line as their answers. Any questions on this set? All right. This was the last section in chapter 3. So polynomials are over. Finding zeros of polynomials over. Solving inequalities involving polynomials and rational functions over. Okay? End of it. Now what's coming up next is brand new subject. Exponential functions and logarithmic functions. We are going to learn about them, logarithms and exponential functions. That's chapter 4. But it's going to take a while to go there. We need to first prep ourselves with some basic information. Okay? So to come to that exponential and logarithmic functions, we are going to first learn how to find inverse of functions, because we will see that one is the inverse of the other one. Logarithmic functions are inverses of exponential. Exponential functions are inverses of logarithmic. So we need to learn what it means to be inverse first in 4.1. Okay? I'm just gonna give you the definitions and basic example today. We don't have time to cover everything. We will continue the remaining part next time. Let's take a look at one example from our daily lives actually, where inverse functions, inverting an operation or event, how do you take it back, undo something you did? Okay, where does it happen? It happens in changing currencies. Like you travel outside of the United States, like Europe, you need their currency. It's called euro. Okay? And the basic formula to change $1 American to euro is you multiply whatever dollar amount you have in your pocket by 0.8. It's a little bit more valuable than our currency. So if you have, for example, $100, you multiply by 0.8, they give you back $80. And now you have 150, you have, it transfers to 120 euros, $200 is 160, $250 is 2 euros. Okay, everything is nice vacation, you're gonna go back to your country, but you have a lot of euros in your pocket you haven't spent. You just changed too much dollars to euros. In the airport, you need to go back and change them back to dollars, right? Because you can't spend euros here. So what did they do? They have an inverse calculator. The keyword is inverse. They have to undo what they did earlier. They have to put those euros back to dollar. So they come up with a new function. And each euro you give them, they divide by 0.8 this time and compute how much dollars it makes. Like if you have 80 euros left in your pocket, they will give you back 100. They cut some commission, of course. This is not exactly true, but 120 is gonna be 150, 160 is gonna be 200. So what's happening? They are undoing something they did earlier. You used to couple 100 with 80. 100 was going to 80. Now 80 is going back to 100. It's going back, inverting, inverse. Okay? This is where inverse functions happen in real time, real world. It's basically a new function. Look, they are not same. It's a new function, so we call it a different letter. It's no longer f, g. Variable is matching though, x, but the numbers are quite different. This is 0.8, this is 1 over 0.8. It's actually 1.225, right, when you divide. So inverse functions are not just flipping operations or minuses. So it looks like we flipped 0.8 to 1 over 0.8 because our function was so simple and nice. But usually just flipping signs or inverting, flipping numbers is not gonna work. Okay? So does it make sense? Again, finding an inverse of a function means you're flipping, look, domain and range values. 100 was in the domain. You put it in x and you compute y. This was y, this was x. But when you're coming back to United States, now euros is your x and 100 is your y, dollars is your output. Euro going in, dollar coming out because you're coming back to country. Okay? So flip domain and range values when you're inverting. When somebody asks domain of an inverse function, it's actually the range of the original function. Okay? So these statements are crucial. You need to observe this and understand. Again, for a function and its inverse, the values x and y are interchanged. Domain and range are changed, okay, replaced. And this is essential as well. Look at this graph. This is the original, orange one is original. No, which one is original? The blue one is the original. This is dollar to euro change, dollar to euro. But the orange one is euro to dollar, inverse. This is inverse, this is the blue one is original. But what happened here? What do you see? Y equal x is our straight line going between x and y axis. These two lines are symmetric of each other. I mean, when you fold that paper, there is a white paper here. When you fold it along this line, this orange graph and blue graph coincide each other when you fold it. So symmetric. So how is this helpful? In later questions or later courses, somebody will give you an curve of an original function and they will ask, can you figure out the graph of the inverse? All you need to do is fold it across that y equal x line. Okay? For example, let's test. It looks like computer is telling me time's up. Yeah, let's stop here. Okay? Tomorrow, remind me, I'm going to show you the relation symmetry on a other much more difficult graph.